Take your pick. Now, we're going into a cos plus cos. Cos plus cos is the top. Double the cos. Well, these arguments, you can notice here, these arguments are going to be the same. Nothing's going to change. So I'm going to get 2 theta and theta. But this time it's going to be double cos cos as opposed to double sine sine. So that goes. Okay, that can cancel. That can cancel. And now we have sine of 2 theta over cos of 2 theta is equal to tan of 2 theta over cos of 2 theta. Okay, so the identity is true. And of course, if I had left this at tan of 2 theta, we can just keep moving this along and say, but sure, the sine over cos with the same argument is tan. Okay. Okay. Well, he can tidy up. There's a 3 theta there. More about him in a minute. I think he might just suddenly disappear. So basically, don't be intimidated by things you don't know what's going to happen with, because especially here, I think we're going to get a surprise. So we're going with a double sine, a sum of a sine. Look for your sum of a sine, and off we go here. So let's write the top as is. Top as is. What am I writing? 4 then. That's 2 sine of 3 theta, 3 alpha. Over, so on the whole bottom line we want to come up with our identity. So it's going to be double, and it's sine plus sine. Sine plus sine. Double the sine of 6 theta over, oh there you go, 6 theta over 2 is 3 theta. So double the sine, and when I 3 alpha I should say, but when I say there you go, because I see there's a cancellation, but we'll do the cancellation in a moment. You know, you've already done it. Oh, pretend I didn't. Cos of the difference, 4 take away 2, 4 alpha take away 2 alpha is 2 alpha. Half of 2 alpha, I'm not going to make that mistake again, is alpha. Okay, so I get alpha. Okay, and according to them that should be equal to this. Well, the 2's cancel, and yes indeed, the sine of 3 alphas go. And you're left with nothing. The only one factor standing that isn't a unit factor is the cos of alpha, and it's proven. Okay. Sum of 2 tans, sum of 2 sines. You don't ever hear that expression, by the way. You don't hear the sum of 2 tans. Sum of 2 sines. Sum of 2 tans. Well, you would do something else with it. Sum of 2 sines here. Double the sine of 3 alpha, that's 6 over 2. Difference is 2, divided by 2 is 1. Times the cos of alpha. Use that. All over again, you're seeing this idea, well, if it's the same angles, all you got to do, you know, you can already say it's going to be 3 alpha alpha, so you don't have to repeat that. Okay, you just need to go and say, well, what happens when the plus has turned into a minus? So instead of being sine plus, it's sine minus. Well, it's down here below, and what happens is it turns into 2 cos sine, which is pretty extraordinary and pretty cool. We're happy with that. The 2's cancel. With the sine upstairs there, that's tan of 3 theta. And when the sine is downstairs and the cos is upstairs, what you have is you have a tan at the bottom. You should be able to convince yourself of that by reciprocation, and this would be at Leaving Cert higher level maths. That would just be just keyed in there without any justification, because it is already justified. But you could bring him underneath there as well and say this is sine over cosine, whatever way you want to do it, and that's fine, except I used alphas instead of x's the whole way through. So just fix them up and you're done. So it's true. So we're going on to 16. Prove that this is true. So first of all, Well, I could be tempted. I can switch this to b minus a over 2 and swap him out. And explicitly, you're one page away from showing why. However, there's no reason to believe that that will be moving me closer to the way I'm going to end up here. And of course, if I don't, you know, I could also swap them by negating and then kill that. There's lots of things I could do, but none of them are for any good reason. Okay, what I really need to do is knuckle down and use the formulas. Okay, so back onto this page. And it's the cos of A take the cos of B. It's the difference of two cosines. So that's just straight up, no messing around, this entire formula as it is. Which is negative 2 the sine of A plus B over 2 times the sine of A minus B over 2. That's that formula there. And then we're also going to have this. What's the sine plus a sine is equal to 2 times the sine of A plus B over 2. The cos, now that's important, A minus B over 2. So while they cancel and they cancel, the negation is still there. And this is the sine of something over its cos, which is the tan of it. So I get equals minus, there's your minus, this is the tan, and it's A minus B over 2. And we've proved it. Okay, and there was no reason to start nudging him towards the middle. It's best really to just let one completely change. So what you have done is you've made the left hand side equal to the right hand side. And you've done nothing. You always never do anything across the equals line, because it isn't an equals line. It's an identity, meaning it's always true. It doesn't matter what A and B is. So 17 is the next one where we actually have an answer in the marking scheme. So let's see why that would be. Write the sine of 105 plus the sine of 15 as a product. So this is a problem. We haven't done anything like this before. But it's the sum of two sines, so it makes sense to think this will be our way to go as a product and blah blah, and hence show this. Okay, so the answer is going to be root 6 over 2. Well, we'll come up with this answer. It's nice that they told us, because it'll tell us whether we're right or wrong. But either way, we would have ended up with this no matter what. So we'll kick this off as being the sum of two sines, which is the second from the bottom. And it's 2 times the sine. You add the two angles together, giving yourself 120, and divide by 2 is 60 degrees. That degree symbol is very important, by the way. Otherwise you're talking about radians, because that's the way the notation works. On to the next little bit here is cosine. And subtract 15 from 105 is 90, which is a big problem. But I forgot to divide by 2 again. I've fallen for that once, I'm not going to fall for it again. Okay, so that's great. What's the cos of 40? That's 1 over root 2. Okay, and what's double the sine? So, well, let's just deal with this one bit at a time. Sine of 60, so it's root 3 over 2. Okay, so I need to get you over the line and get you good results one way or the other. So if it's a case that you do not know that the sine of 60 is 1 over root 2, you've got this option, but that's slow and messy, and you've got to make sure you're not giving a decimal readout when it's a third answer. And you've got this option. Now it's not the best way. The best way is just know it. But the next best thing is to go here and look up the sine of 60 degrees. And it tells you, and as long as you know how to look up a table, which is a great skill in its own right, it tells you it's root 3 over 2. And similarly, the cos of 45 degrees could plug that onto your calculator too, and it'll do all this for you. But the cosine of 45 degrees is 1 over root 2. And we do not, and certainly I would say you're probably going to, well, I'll use this one anyway. That's probably the one. I sometimes like to use the older plus because of the fact that the text is bigger. But so we're going to go double. So my suggestion would be, this is all very well, and I can certainly, I don't like this, because they have rationalized the denominator. Let me write that down. Rationalize the denominator. They have, you should never leave, like in the olden days, especially before calculators, they would always, they would never be allowed to be a square root at the bottom because you couldn't calculate it. So you would do pen and paper to get rid of the square root. And to use pen and paper to get rid of the square root, you'd put root 2 over root 2, making this 2 cancel with them. Now you've simply a 2 down here and a root 3 times root 2. And a root a times root b equals root ab. Again, I can show you in algebra where that is. So it's up around page 20, I think. 21. Square root, what did I do? Square root of a times the square root of b. Square root of b. Did I not give you that identity at all? Maybe not. Kind of in a roundabout way give it to you there. But they're basically saying any power, and in this case the power is a half. But of course it's true. Okay, so the root of 2 times the root of 3 is equal to root 6. And then downstairs there was 2 left. But after all that you say, that was a big long lecture, wasn't it? And you could have just gone 2 times the sine of 60. Because sine of 60 is a number and the calculator knows everything about it, times the cos of 45. And your calculator is just going to spit that out at you. So when push comes to shove, that would have been, of course, a way better way of doing it. Keep that in mind. When in your exam, you're not going to be a martyr doing all this maths, but I think you learned something anyway. From you learned the expression rationalize the denominator. Right? And yeah. And it's funny, they wrote down just 2 sine 60 cos 45. But of course, for a proof, there is no way to write down an answer. It's true. Oh, they did say write it as a product. So that the answer to that was 2 sine 60 degrees cos 45 degrees. And that's why they're writing it. Now, what kind of a product? You could call it a three-way product, but we often like to call that just double, and we think of it as being double because this is the interesting bit of a product there. That's the way I think about it anyway. When it comes to dimensional analysis, that's quite important. So if this was a distance and this was a distance, then this will never be a distance. This is simply doubling. It's a pure number. In this case, these are pure numbers too. So we're going to write this as a difference of 2 cosines. And what I maybe want to do is start, putting down actionable things. What's the question? I think that's really a question. I must tick the box here when that's done. And then hence, so there's two tasks to do. And if I don't do 2 of them, I'm not going to get full marks. Okay, so write 2 sine 45 sine 15 as a difference. Okay, so we'll go back and do our little game here, even though it's not very far back. So now I'm gone too far forward. I know I'm 1 page back. And do not spend 2 years frustrated not knowing the order of this thing. It's a small enough book. So we pop this up like this. We put our thumb here. And we say it's double a sine sine. Oh, sorry, we're up top. It's a double sine sine. That's the second from the bottom here. Third from the top. And it's a cos. And in your exam, the type of time you'll have, you'll be perfectly justified in writing it down to give you, so double sine sine. But don't make the writing it down be a source of error. So if you're going to write it down right. Keep your thumb on it, or take a ruler, and that ruler is too long, okay, you'll end up, it's just too messy, so take a shorter ruler and keep it on it, and nothing wrong with that sort of policy. And that's a bit short too, just being totally silly here, so I want to go for my rulers of every sort of length, as you know, and that's the absolute, so a 20 as opposed to a 15. Okay, you know I'm going over the top, but at every level of control. So, but it's nice. You can slide it from either side. So go for a 20 centimeter ruler, and if you don't have one, and just go get yourself one or cut up one of these. Bread knife will do you. Okay. Now be careful of them though, because maybe supply. Who knows where supplies are coming from for the next while. So if you have a full length, leave it alone. Okay, so what I was saying there is be extra careful about I'm stuck for the word now, but about writing out the formula again. So to double sine is just, so as you're working along here, be extra careful and make sure you know where you're at, okay? It's quite easy. There's a lot of other information that's very similar and distracting, or very nearby. Then you want to maybe write up here to, now I haven't done all the rest of them this simply, but I'm just playing devil's advocate, and I'm thinking what could go wrong. I think if it could go wrong, if it can go wrong, it will go wrong, but it can't go wrong if we're this careful. So the 2 disappears. So it's nice to compare top with bottom. We're getting the cosine, and it's easier to put your finger on things here now. So subtract them and add them and use cosine. So it's cos of 30 minus cos of 60. As a difference of 2 cosines. Has that been achieved? Yes, it has.